So some of you are choosing to write this down. Maybe some of you have it done already. And we throw a lot of these concepts together in an activity when we start calculating horsepower. Okay, because our first activity that we do together as a class is not until next chapter. We start studying forces, and what that means is when it comes to architectural design, are some of the oldest buildings that or structures that we see here on Earth. Probably none of them rank as high as the pyramids, but when we talk about Roman engineering, can anyone think of what may have the Romans discovered, or what is that the Romans did in their building? I want to say not concepts, but I'm trying to think of what the right word would be. Their architectural plans. There's something that they repeated throughout all of their different structures, from their aqueducts to the Roman Colosseum to the Pantheon. Yes? Arches. And an arch is just that, how you put it together like this. It can also be a dome, and another structure is also a cylinder. Those are your three types of Roman arches. Some lay on their side. Okay? And for instance, has anyone, I've never been to the Hoover Dam. Has anyone seen that or been there in, my geography is terrible. I know it's the Colorado River, but is that in Nevada? I think it's, yeah, well, Las Vegas, yeah, I don't know what I'm thinking. Because I was going to say that's probably pretty close to the border of California. But if you know anything about the history of the Hoover Dam, I believe at one point that used to be part of a highway system. I think the dam actually had a highway on it to go from one side of the river to the other. Okay. That's water, right? No? All right. But with that, what happens is that's a type of arch that lays on its side, because usually when we picture an arch, it's what's standing up, not laying on its side. So so with that, some of you might be thinking, well, what were the Roman aqueducts? Does anyone think they know? Possibly. Has something to do with water. Yeah. What did? And the idea behind that is crossing different parts of the mountain or a valley. And if you know anything about that, what must you have in order for that water to flow? You can't, what am I doing? It can't flow if it's doing this. What does this look like? Straight, that's level. Water's not going to flow that way. So what they did is to design that so it has just a little bit of a slope to it. And one of the things about that is when you put, let's say, a slope of maybe even as little as 2 inches, when you're looking at a span of 600 feet, that 2 inches is probably going to be pretty darn near 40 feet down. Now that might not make any sense to you, but for those of you who do target shooting, or if you're shooting a deer that is a long distance away and you got a scope, you don't put the crosshairs of that scope right on the chest of that deer, do you? Why not? I mean, isn't that round coming down the barrel going to go straight right into wherever it is you're aiming? Well, gravity's going to have an effect on it, so what do you do with your crosshairs? You do what with them? Yeah, you elevate them a little bit to account for, well, the gravity and the way that round is going to travel. Kind of like the same idea. The further away it is, the different, is it mils? Does that sound right? MILS, you have to account for on your scope and adjust that going up. I think that's right. Now, some people are sitting in here and thinking, I could not care less about this. And I'm not a hunter either, but that's something hopefully that when we explain this, oh yeah, I kind of get that. That's what I do. Maybe yes, maybe no. All right. So you've read that problem. You've wrote that problem down. You see all those different types of variables. What is the question asking ultimately? There's two things. When we talk about the velocity, okay? So you've wrote the problem down. You've read the problem. You looked at it and said, this is what we're trying to figure out. What is the next thing you should do? When you don't do that, bad things can happen. And that's by choice. It's you possibly choosing not to write these down. Okay? So, what do we know? And I just threw these numbers up here. I don't know if this is going to work out the way we hope. We shall see. What else do we know? Now, when you're looking at these, how may people, I'm not saying you people in general, but what mistake can be made when you look at those two numbers? You got to look at the label. Which one's which? Okay? Meters per second squared is an acceleration. So, which one did we say next? I think you said this. I'm sorry, I kind of got off track. It's a velocity, but which one? Final velocity. Okay? And why is it a good idea to be specific when it comes to that, whether it's a final velocity or an initial velocity? Final velocity is used to calculate not only an acceleration, but what else? When it hits the object, it's what? Final velocity. Momentum. You're using that in the momentum formula, which Detroit didn't have much last night. And you were watching ESPN, but I like Matt Stafford. So there again, it's kind of like, this is one of them things I feel comfortable talking about. Star Wars, Star Trek, football. Heck, I'll even talk about volleyball. Don't know much about it, but we'll talk about it. And I don't think I mentioned, how many of you have seen the movie The Blind Side? Okay? And I do this to pick on you ladies. I'm not serious when I say this, but it's so funny. I think you guys, gentlemen, may laugh too. Okay? During the course of the movie, Sandra Bullock is the character that portrays the mom. Was it Colin or it was Colin was the daughter, right? But this is early on in the movie. She's in her volleyball match, and Tim McGraw plays the father, and then S.J. was their boy then. So Sandra Bullock's character is late getting to the volleyball match. So she shows up, and looks at Tim, the character for her husband, goes, okay, so what did I miss? Does anyone know what S.J.'s character said? Now, again, just keep in mind, I'm not serious when I say this, but this is the movie talking, okay? He says, it's girls' volleyball, Mom. You didn't miss anything. So, come on, you people got to think that's somewhat, some of you want to laugh, I know. No? Was that mean? If it was, I don't know what you said, but it made the young lady in front of you smirk, so maybe there's some truth. I don't know. It wasn't mean, I know that, but no. But it was funny, though. Is that true? Are you agreeing with what I said then? Oh, can you sit and watch volleyball? With a lot of people, that's when it comes to a sport they like. They'd rather take place and participate in the sport rather than watch it. I think there's something to be said for that. Okay, so we've got the momentum, we've got the final velocity. What else do we know? Acceleration, which is what? What else do we know? Do we know anything else? That's S for seconds, by the way. Okay, so what are we looking? You correctly answered, but what are the variables that we are looking for? Okay, so question mark, question mark. All right. So, let me look at some of my notes here. Okay. All right. So now, we need to pick. Can we solve for both of them? Yes, we can. Okay. So you need to pick one. Okay. So where do we see initial velocity in a formula? Okay. So we know that any acceleration equals what over what? Okay, so we know the acceleration. So there again, once you have all this information here, you don't have to keep looking back up in this problem. And we can say, oh, our acceleration's there, 2.72. I don't know what I did that for. I should have kept going. Did anyone say, no, you're doing that wrong? Would anybody have said anything? No? Just saying, well, shoot. How do you know I'm not just making this up as we go? Maybe this is all false and fake, and wouldn't that be terrible? Maybe. Okay. Well, there's an author that we go through that's where this material comes from. They got a PhD in this, so they must know a little something. 2.72. So we want to do with that formula correctly what that formula tells us to do, which says take the acceleration and set it equal to what? Okay? Oops. See? We'll see if anybody was paying attention. Sometimes you just do this by habit. Not seeing if you're paying attention, but just going through these formulas. 1.91. Okay. Because what could happen on your exam is what would happen if we didn't know the final velocity? Could we find that with this information that we know? Some of you are shaking your head, yes. Is that true? Yes, we could. How could we find the final velocity if we were not given that? From which formula? Your momentum formula, which means the product of a momentum, this, would equal this times whatever your mass is. Okay, so some of you may be looking at this and saying, gosh, we got that darn fraction. I hate fractions, you might be thinking. So how are we going to get rid of that fraction? Okay, we can put 2.72 over 1. All right, that's fine. Okay, so how do we get rid of our fractions now? Cross multiply. So what's 1 times 9.1? 9.10. But we got to take 1 times the negative VI. And what do we get? Negative VI. Remember, a number times a variable gives you that number and its variable. So we're going to set that equal now to whatever 2.72 and 1.91. What do we do with them two numbers? Multiply them, and what do we get? 5.19. That's good enough. Okay. Now, when we're getting these variables isolated, what is the difference between this type of, what I want to say, operation as opposed to this operation? That's not written very well. There. In other words, how do you get VI by itself in this type of an operation? Divide, because what are you showing here, what you're trying to do? Multiplication. How do you undo multiplication? You correctly said you divide. If you have this on this side, really this is a positive number, so how do we undo the positive aspect of 9.1? We're going to subtract it from each side. So, if we subtract 9.10, what do we got to do to this side? What happens is these two variables, or not variables, numbers, they're gone because they cancel each other out. We've accounted for that on our right side. So, when we subtract 9.10 from 5.19, we get what? I heard a negative. Okay, what's left over on our left side? 9.1? Okay. Okay, what's left on, what do we have left on this side of the equation? A little more specific. What's wrong with how that's set up right now? What did we say about all velocities? Velocity cannot be negative. You're telling me that's velocity is negative. No. What do we need to do? There's one of two things you can do. Just tell me. We've got to carry that down. There was a negative sign on our velocity. This still has to go down. So now, there's one of two things you can do. You can either multiply by -1, or you can divide by -1. In either case, once you do that, that changes that to a positive value. Now you can see we can't have negative velocities, and this proves that. Okay. This is probably one of your tougher problems that you could face that's pretty similar to this. Okay? So the only way that it might be a little different on your exam on Thursday, the problem solving part, is maybe you would not be given this variable, the final velocity. But you would have to have the mass in order to solve that. But how are we going to find the mass from this set of information? Okay, so your momentum, which is 8650, okay, 8650 equals what on the right side? Okay, and what else? 9.10 m. So just like we illustrated earlier, this was a subtraction function. This is a multiplication function. And how do we undo multiplication? By dividing. So you divide each side by 9.1, and that would give you your answer. But we'll let you go ahead and go through and do that. Just for my own benefit, I just want to see if we're We're writing this information. Oh, I got to get this written down, or do you? Following along? Okay. All right. All right. So, how many people outside this room know of the Science Channel now? Is that holding up a number, or that's your number, huh? You're just saying that they know, or is that this number? Okay, very good. It's one thing to know about the channel, but is it being watched? Because I can just look on the Science Channel, it's going to tell me how many views are actually on there and how many people are actually watching. Okay, so keep that in mind. So now what we want to have you do is, if you're having problems with this, you can go back through and see once what we did. And we can talk about, your parents have this opportunity to go to the science website, says link to Science Channel, and your parents are more than welcome to click on that to see what it is you people are doing in class. And maybe we should put up another computer and face it this way to watch what you people are doing. So you can be on camera too. Wouldn't that be great? What's your opportunity to be on camera? Be the next star. No, you'll pass? Okay. All right. So, again, one of the things that could happen is you may need to solve for a problem like what we did yesterday. You were given time in that hockey game, but you had to solve for time. That's two totally different things. Sometimes you need to find an answer and compare it to the information that was given. In other words, there was, I can't remember how much time was left on the clock, and who was our hockey player is in the back left corner there. What? You were watching? No, but you said you knew stuff about hockey, so you're our hockey player. So you took your slap shot, but with the time left on the clock, did the puck meet the goal in time? No, it did not. Yes. Yes. Okay. So, do we feel we need to go over anything else? Because I think we had an example where you might see something like this again. There is a deer or a gazelle that's within an immediate area called the kill zone that predators try to cover in a certain amount of time. So is this animal going to be successful going after a prey item? You may be given a time, but you need to solve for that compared to what actually takes place. Because what happens is, what do we know about the fastest land mammal? The cheetah. Okay? So the longer that a gazelle stays in front of that cheetah, every second that passes is going to extend that gazelle's chances for living. Okay? Because the longer it stays out in front, it's going to be able to get out of that zone. Because how many of you are sprinters in track? So when we're talking about sprinting, once you get towards the end of your 400, we're going to say that you're probably not running as fast as you were at the beginning. Does that make sense? Okay? Does anyone run the 800 in here? That's a sprint. That's what I was told when I was your age. It's a sprint. Yes. Cross country. That's a sprint. Maybe the last half mile, right? Okay? So, keep in mind, okay, we'll wrap this up here in just a couple moments. Keep in mind, we had problems where, let's say, a good one would be when the pioneers wanted to see if they could use this open air as a shaft for water. So what they would do, well, I don't know if this is the case, but to determine the depth of that, okay, you could hold a rock over the opening, let it go, and do what? 1, 2, 3. All of a sudden, you splash. Okay? So with every second that had gone by, how far had that rock dropped because of gravity? How many meters per second squared? You know the value, you're just not thinking of it. The value for gravity. It's between 9 and 10. A little higher. A little higher. 9.8. Then I remember that. 9.8 meters per second squared. That's going to be important for next chapter when we start talking about forces, because you're going to have to take a mass times an acceleration. Usually it's due to gravity. So, if you have any questions over these, please come in and talk to myself. Again, this section is not until Thursday. So if you have problems with that, find an upperclassman, find a classmate, find another teacher, come talk to myself. You have many opportunities to do so. Okay. Now, how many of you have had older brothers or sisters go through this science curriculum? Okay. Do you know what it is they may choose to bring home to have your parents sign? Maybe you've seen them before. It's something by choice. It's something that you choose to do. Okay? Maybe you do or don't want to know. You want to know? Okay? They're bonus questions. I don't require you do them. It's by choice. You do it, fine. If you don't want to do them, that's fine too. Okay? Now, it's one of those aspects to where when they're given, they're due tomorrow. Okay? All it is just a couple questions. Chances are your parents are going to know the answer, because it's 2 points for every question. Okay? 2 questions. How many total points is that? 4. And if you have ma or pa or a legal guardian sign it, you get 2 more points. Okay? And when you, just to do the simple math, let's say on a 60-point exam, didn't quite do as what, or 70-point exam, you didn't quite do as well as you had hoped. So you get a 58 out of 70. Okay? That's an 83%. I mean, it's still a B. It's not terrible. But you take that same grade, and we take 64, because we said 58 out of 70, but now you chose to do those bonus questions. We put that on your exam score. Now we got 64 divided by 70. That's now a 91. Okay? That's a lot of points. So when we say we don't give extra credit out, we don't. It's because of this scenario right here. This is giving you the most amount of points where it counts the most. If we said, okay, we'll do extra credit, it goes in your daily grade. That don't count for a whole lot. I just allow for, this is your responsibility to get free points. Okay? So just keep that in mind. Again, they're due tomorrow. Okay. So any question over that? Okay. And then what you do is, this is a biology test, for instance. That's why you see these papers stapled to there. Okay? It's because they chose to do these bonus questions. Now, it's one of the things I forgot to mention, but from now on, you need to have don't just put the answers on here. What you're doing is you're just copying somebody else. Now, will that happen? This is maybe what had happened. So you need to have the question and the answer on there. Okay? Let's see here. Like here I got 4 exams, and 2 of them are choosing not to do that. Okay. So I know you got a volleyball match tonight, so I want to get this wrapped up so you can go ahead and look over this material, or it's your opportunity to ask any more questions, whatever it is you feel most appropriate. Okay? And don't say the answer out loud, because if you do, well, then I just strike that. Then you're down from 2 questions down to 1. So if you want to be the person that, I know the answer, I'm going to say it, well, then you're going to have lots of friends in here real quick. Okay? So, who was the mayor of New York City? Well, because a mayor serves a term limit, I think 4 years. So who was the mayor in New York City on this day 17 years ago? The blank is what his name would be. Okay? So you write this down. Chances are your parents know the answer. You write that in here. Any questions over that? Okay? Okay. Some of them are factual. Some of them, that's kind of neat. At that time, you learn something every day, we hope. Since we're talking about New York, let's go ahead and now in baseball, what does this stand for? New York Yankees, okay? Okay? So it's a nickname that many baseball players from teams from New York had, because they probably hit lots of home runs, so they would call them the blank bombers. Okay? And then finally, usually when it comes to like signing legal documents, usually for like, let's say, tax returns, marriage license, anything like that, say there's a line here and they say signed by the what? Well, I mean, on this line, say signed by the what? That's what the X means. Say signed by the X. Okay? So human nature as it is, you forget this paper, you wanted those extra points, but I can't give it if your parents don't sign it. But first hour, oh, Ms. Doctor, what are the answers to these questions? Or I got the answers. Well, you only get 1 point for that. It's you taking the initiative to do that. And you don't have to do these. If you're not writing them down, that's entirely up to you. Okay? But those have to be turned in tomorrow because Thursday's too late. All right, so you have some time to ask me any more questions that you may have. Otherwise, the rest of the time is yours.